Alright, quick video today just with a couple of examples on some harder equations involving fractions. So here's the first one. If I see there's two fractions with the thing I'm trying to solve for in both of them, most often I'd want to try to remove those fractions first, so remove those denominators. Now both 4 and 6 go into 12, that's the lowest common multiple, so the easiest way to get rid of them is to multiply everything we see by 12. And the effect of this on each of those terms is as follows. Look at the first fraction first. What's the effect of the times 12 on the over 4? Well, 12 divided by 4 is just 3. So we get a multiple of 3 outside the 2y minus 1. Likewise with the second fraction, what's the effect of times 12 on the over 6? Well, 12 divided by 6 is 2. So we get a factor of 2 appearing, a multiple of 2 appearing, outside of the y minus 2 in brackets. Now the most common mistake I think I see in this one is people forget to multiply the negative 1 by 12 as well, but you got to make sure you do that. And so that just becomes negative 12. Okay. Now, once you've done that, you just need to expand everything on the left-hand side. So we can quickly do that. I think I'll just go through this quite quickly this time. Just be careful, the negative 2 times negative 2 gives you a positive 4, so look out for that stuff. And then on the left, we collect our like terms. 6y minus 2y is 4y, negative 3 plus 4 is 1, and then we can solve that as normal. I would subtract the 1, and then divide by 4. Please don't freak out if your answer is a fraction. I've had quite a few people email me questions like, I'm stuck, but your answer was just a fraction. That's okay, right? Do check your work, but it's okay if your answer is a fraction. Okay, last one. So the idea is the same, even though it's going to look quite different. The idea is when I see there's a bunch of fractions involving the thing I'm trying to solve for, I want to multiply by those denominators to clear them out. Okay, so if I see there's an x plus 5 and an x minus 2 on those denominators, I have no choice but to multiply by both of them to get rid of those denominators. So on the left, all the x plus 5, the yellow one, all that will do is get rid of the x plus 5 on the bottom. And on the right, all the yellow x minus 2 will do is to get rid of the x minus 2 on the bottom. They'll cancel. And so what you're left with is on the left, 2 gets multiplied by x minus 2. On the right, 3 gets multiplied by x plus 5. But this, again, happens in brackets, and so you end up with this. And so again, we just need to expand both sides. This time I'll subtract the 2x from both sides to get rid of it from the left, leaving you with just negative 4 equals x plus 15. And at that point, you should be able to see by subtracting 15 or whatever that x is negative 19. Okay. And there is maybe a quicker pattern you can see after you do a few of these. I'll do it on the bottom right corner there. And the pattern really is when you multiply both sides by that denominator, this is going to happen. And so you're going to get that. And so I guess the way you sometimes see it written in books or people talk about this, maybe your teacher will talk about it, is that you can multiply along a cross. So we call it cross multiplying. But really, it's just multiplying the denominators and seeing the effect of multiplying both denominators on both sides of the equation. Okay, so that's what we will call cross multiplying. If you ever hear that being said or see it written in a book, that's all it is. But more importantly, why it works is what we did before. Okay, so that's how you solve those ones. Have fun with that. See you next time.